Right, in this program we will look at how to write interrupt driven programs in C language. So we are in Keil Microvision 4 and we have included reg52.h, which is a header file which contains a list of all the addresses of all the pin numbers, all the registers, etc. Then we have our main program, and inside our main procedure we have void main, and then we have a never-ending loop over here which is while 1. Now over here we can see that in the main procedure we have nothing but initialization statements where we have initialized the interrupt enable register. So we've enabled the most significant bit, which is the global enable disable bit, and we have enabled the interrupts for the two timers. So both the timers will be working in this program. Then we have initialized timer mode registers, so that we have initialized timer 1 in mode 2 and timer 0 in mode 1. Then we have declared two variables which are of type character A and B, and we have initialized them to 0 in the main procedure. So over here we have initialized them to 0, and we have also automatically set the overflow flag for timer 0. And why we have done that is because we have intentionally caused the overflow to occur for timer 0, so that its interrupt is generated and it goes to its interrupt service routine, and we initialize all the registers that we want to for timer 0. Then we can see that we also have initialized, or we have associated pin number 1.1, 1.7 and 2.0 to SW, SW1 and SW2 identifiers respectively. Now we will be connecting 3 LEDs to each of these 3 pins, and when the program starts up we have switched off the LED connected to SW. Then we have initialized TH1 with the value 6, and we have started timer 1. So timer 1 will be working in 8-bit auto reload mode. We have initialized it with 6. So remember how it works. Every time the timer overflows, it picks up this value, places it in TL1, and then starts counting upwards until it reaches 255, and then it overflows. So basically in this case we will be getting a delay of 250 microseconds because all the registers are 8 bits wide. And then we have a while 1 loop. So it is a never-ending loop, and it keeps on waiting here but does nothing in the main program. And now let's look at how we have written the interrupt service routines for the two timers. So here is how the interrupt service routine is written for the timers. So we have void timer 0 void, so it returns nothing, it takes no parameters, and the name of this interrupt is interrupt 1. So this has to be there, whereas this is any name which you can give to it. So interrupt 1 is sort of an operator that is associated with timer 0. And how does this work? All the interrupts of the 8951 have a number associated with them. So external 0 has interrupt 0, timer 1 interrupt, timer 0 interrupt has interrupt 1 associated with it. Similarly, timer interrupt 1 has interrupt 3 associated with it. And this is how we have used it over here. So void timer 0 void interrupt 1, this is the main thing that you need to remember and you need to be careful about. So every time timer 0 interrupt occurs, the control will automatically come into this procedure. And here we have toggled the SW1 pin, which is basically pin 1.7. So the LED connected to this would be turned on if it was off initially, or it would turn it would turn off if it was on initially. Then we are stopping the timer and we are reloading the values of TH0 and TL0, because remember this is mode 1 and we have to reload these values every time. We are incrementing A by 1, and when A becomes 20, then we are incrementing B, and we are making A equal to 0, and we are switching or we are toggling this LED. So basically 3CAF, if it is if you convert it into decimal, it becomes 50,000, and if this loop is run 20,000, if this loop is run 20 times. So if this loop has run 20 times, then a delay of 1 second has been achieved, and if this B has reached the value of 2, it means a delay of 2 seconds has been achieved, and this LED will be turned on and off accordingly. So we have 3 LEDs which are turning on and off at different times depending upon the values of the timers. One LED is turning on after 1 second, another one after 2 seconds, and then we have a third one which is turning on more frequently. So you need to check this one by one, and you need to implement the circuit.